Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the pneumatic and hydraulic actuators. What is called pneumatic and hydraulic actuators? Why it is used in the robots? Why? Because according to the pneumatic and hydraulic actuator process, the robotic operation can be performed. Okay, pneumatic is Pneumatic is the one which is performed by using the air pressure, where the hydraulic actuator performs according to its pressure by the liquid. Okay, we can see what is it. First is actuators. What are the actuators are the device which provides the actual motion force for the robot joints. Actuators are the device which provides the actual motion force for the robot's joints. To the joints, the force will be provided by these actuators. Okay, actuators are like the muscles of the human arm and hand. Actuators are like the muscles of human arm and hand. Actuators are classified based on their sources of power as hydraulic actuator, pneumatic actuator and electric actuator. Sources of power, the actuators can be classified into three categories: hydraulic actuator, pneumatic actuator and an electric actuator. Hydraulic actuator, as I told you, it is mainly based on the power, source of water or a liquid, oil likewise. Pneumatic, it is based on air pressure. Electric, it is based on the electrical supply. Okay, we'll see what are they. Hydraulic actuators. Hydraulic actuators are powered by pressurized oil. As I told you, it is powered by pressurized oil. Once the oil gets pressurized, the robot's arm or a robot joints can be moved according to that. Okay, hydraulic actuators are designed to operate at a pressure of 1000 to 3000 psi and are hence suitable for high power applications. Okay, hydraulic actuators are designed to operate at a pressure of 1000 to 3000 psi and hence it will be suitable for high power applications. Hydraulic actuators are mainly designed to perform high power applications. Okay, we can see the diagram image which is an hydraulic actuator. Okay, this is an hydraulic actuator setup. What are the oil reservoir is present, oil filter, which generally the pressure of oil can be measured. By pressurizing the oil, the movements can be done, right? So we'll find oil reservoir, oil filter, hydraulic pump, pressure indicator and shaft of valve, hand shaft of valve, pressure relief valve, okay, feed line, hand control, four-way valve and a double acting cylinder. Okay, from the oil reservoir, the oil will be pumped into the oil filter where the oil gets filtered and then it will be moved on to the hydraulic pump where the oil gets pumped and the pressure it will indicate, then it will be moved on to the it will be pumped and then the indication of pressure indication can be measured and then it will be moved on to the four-way valve. Okay, four-way valve. From four-way valve the oil will be inletted to a double acting cylinder where by using push pressure the oil will be pressurized and it will be again moved into the return. By using feed valve, we'll have four-way valve, right? In that the oil gets pressure and it will be moved on to the double acting cylinder. There it will be again pressurized and it will be moved to the feed return lines using hand control shift lever. Okay, the pressured oil will be moved on to the four-way valve again and then from there it will be moved to the again oil reservoir using this return lines. Okay. These are as I told you in this that block diagram, what are the things present? It is the same one. We'll have a variable displacement pump, reservoir, check valve, free filter, accumulator which is used to store the oil, which can be used when the source has we have a limited amount of source. We can store when we have a limited amount of source, we can use a stored source which is present in the accumulator. Double acting cylinder, inertia load, linear spring. Okay. The oil, the source of the power for hydraulic actuator, is stored in the reservoir. As I told you already, the oil will be stored in the reservoir, and then the oil is first filtered by the oil filter. The filtered oil is sucked using the hydraulic pump. The valves are used to control the flow of the oil in the circuit. There are 4-way valves which allows the flow of oil in forward and in the reverse direction also. Okay. The flow of oil in the forward direction is via the third line, and in the reverse direction is via the return line, as I told you already. The pressurized oil actuates a piston inside the cylinder. As I told you, this double piston cylinder, right? Will have a piston over there. And the pressurized oil actuates a piston inside the cylinder, which causes the actuation of joints in the robots. Once the pressure is given in the cylinder, according to that, the robot's joints can be moved. Okay, these are hydraulic actuators. We have an accumulator also. As I told you, accumulator is used to store. It is a storage device which stores the which can be used when there is a sudden demand in power. The oil can be stored, and once we have a demand in oil, we can use that stored one. Okay. Inertial load, linear spring, and a viscous damper represents the mechanical system of the robot. An important contribution to be selected is the bulk modulus of the oil. What is called bulk modulus of the oil? If the bulk modulus of the oil is high, the robot is stiff, quick responding, and pressure buildup is fast. Once the bulk modulus of the oil is high, the robot is stiff, quick responding, and the pressure buildup is faster. If the bulk modulus is low, the robot is loose, slowly responding, and the pressure buildup takes a time. Okay, these are the bulk modulus of the oil, and these are the hydraulic actuators, how it works in the robots. Thank you.